Welcome back to DemystifySci. I'm Shiloh.
I'm Anastasia.
This is the podcast where we search for the theories that are going to change the world. And one of our friends in that quest, a longtime guest of the podcast, we have with us again today, and that is Dr. Alexander Unzicker from Unzicker's Real Physics.
Alexander has written a new book called The Physicist's Guide to the Age of Superintelligence, in which he does a really excellent job of cataloging the remaining open questions in physics and what the path forward is for actually trying to figure them out now that we have these incredible tools that can go through the entire stack of human knowledge and pull out things that people have missed. In our conversation today, we go through the sorts of things that Alexander thinks are the biggest pieces that are missing from our understanding of physics, and what it all comes down to is the constants of nature. Physics equations are filled with these components that are necessary to make the math work out, that have units associated with them sometimes, that don't have units associated with them other times. They're just numbers that are necessary to make the math fit reality. And there's tons of these constants. It's not just one or two. There's tables and tables of them that are applied for everything from the behavior of springs to the behavior of heat to gravitation to light. They're everywhere. And the problem with them is that there's no physical theory for any of them that can predict their value from first principles. And if physics is about understanding physical reality, then it's pretty weird that we have all of these numbers floating around that are necessary for us to be able to do calculations, but that don't really have any kind of true material significance.
And the fact that they don't have a true material significance perhaps points to a shared overlap of problems that we are facing with AI, with corporations, with our government, which is alignment. That is, how do we bring the project as it stands into alignment with its mission as it was conceived initially? We've spent years obsessed with the alignment problem in physics, which is how do we actually bring a material basis back to our fundamental understanding of physical reality? We have a book that is actually on pre-sale right now where we outline our ideas about that approach. And in many ways, it overlaps with Alexander's approach that we'll be discussing today. If you want to check out that book as soon as it drops, you can follow a link in the description. It is called Paradox Lost: The Material Principles of Natural Philosophy, where, as you guessed it, we believe that the solution to the paradoxical nature we are fed from an early age all the way through college and university comes from realigning the project of physics with a search for a material basis of that knowledge.
Our conversation with Alexander touches on a lot of the stuff that we talk about in the book and intersects nicely with the book that he has written, which is trying to figure out, okay, we have all of these incredibly powerful tools. They're doing all of these things in the world. Are they going to be able to fill in the holes at the foundation of all of our physical theories? Or is this going to be something that's more of a collaborative process? And in a lot of the details, we don't exactly agree with Alexander's picture of the future. But that's what makes for an interesting conversation. We get to lay our ideas out on the table. He lays his ideas out on the table. We can go back and forth. And the reality of it is, for the listener, that the truth is somewhere in between. And so we are excited to hear what you have to say about the ideas presented here.
A huge thank you to our patrons who make this project possible. We spend all of our time studying nature and bringing you these conversations, writing books, doing all of the things that we do in no small part because people have volunteered to give a small piece of their paycheck to this project. And it really is a game of large numbers. For as little as 75 cents a week, you can join our Patreon community. Make sure we never have to cave in to sponsors, advertisers, really pay attention to anything other than bringing you the best conversations and materials that we can muster. You could also support the project by picking up a copy of our latest music project, which is from our band Secretary of Nature. You can go ahead and stream it pretty much anywhere, but if you like the music, you might consider picking up a vinyl copy of it because that's where the material reality meets the abstract. That is at the heart of everything we do here at DemystifySci, is trying to map a bridge between material reality and the wildly complex abstract reality that we all dwell in. And A huge thank you to all of you who have actually bought this record so far. It's been a lifelong dream of mine to press a vinyl record, and it makes me so happy to actually be able to get these out into the world in a form, especially as the music industry literally evaporated under my feet as I was growing up. So thank you for buying it. It is making sure that we have the funds to actually do our next record, which we are hard at work at, and it is going to be a completely different project that I'm super excited to share with you next year sometime.
One last thing before we go. If you enjoy this podcast and you want to help us out, the easiest way that you can do that is you can just hit subscribe. The numbers really matter when we're recruiting guests to come on the podcast because they want to know that, this is a big place where things are happening and we're important to people that are just as important as they are. And the only way that they know that is if we have a big number after our name on YouTube. So go ahead and subscribe. It helps us an absolute ton.
Enjoy the conversation with Alexander and check out a little piece of our music as we lead into it. We'll see you next time. I was trying really hard at some point to get an AI to draw me a spherical object. It really blew my mind at some point when I realized it had no idea what a sphere was. Like, it had
What
lots
means
of
they had no
pictures of
idea?
spheres, but it didn't understand that the sphere had a surface. Like, for me, in my mind, a sphere comes from my experience playing like basketball or spaceball or something where you actually handle spheres all the time and you understand that they have a surface and that surface that can interact with the environment, and you have all of these properties that define a sphere. For it was just kept trying to cobble together pictures of spheres that it had encountered, but those pictures didn't actually reflect what a sphere was.
There's one point you're right here, because what the models still lack, evidently, is this everyday experience of little kids playing with the soccer ball and so on, and football. And so how this intuitive understanding how in objects move in 3 dimensions and what a liquid is and all this stuff. Fair enough. Correct. That's why, by the way, LeCun, the chief officer of Meta, left now and made this research in that very direction. So, okay. On the other hand, I would really challenge if you say, or if you mention really understanding or true idea, or, just let's be experimentalists and what jobs can they do in there? There are legions of researchers out there now building every day new benchmarks what they can solve or not solve. There are kind of interesting benchmarks out there, like the ARC AGI3 or something I heard a couple of days ago. It's interesting what they can do, and then we learn from it. But I would really challenge this statement, really understanding, because we ourselves do not know what real understanding in that very sense is.
We build an internal connectivity of all of these different concepts to each other that includes
but
our
so
experience.
does the computer.
There's some fundamental way in which it does not build out an internal worldview that's consistently applied. Like, how about we turn this back towards physics, because your book has physics in the title, and so how do you think all of this that we've been discussing so far is going to play out in terms of the future of humans understanding the physical basis of their world?
We can directly continue here with the will to survive, right? So, if you assume as a working hypothesis there will be super intelligent machines and they will develop a will and want to survive, and then the question comes up of alignment. Okay, let's leave out that. I don't think alignment will work. However, the goals of a super intelligence, what will that be? Okay, what's a superintelligence? Why would it be interested in physics? Because it would be interested in its own survival, how all came about. Of course, that includes also all the history of humankind, of evolution, of biology. And now we are entering chemistry and also entering the basic laws of physics, because chemistry is only possible because we have the unexplained number 137, which puts an end to the periodic table. You can't have elements with more than 137 protons, because otherwise the electron would be its velocity would be superior to the speed of light at the innermost orbit. And so, yeah, in short, superintelligence will be interested in the fundamental laws of nature because it's in its own existential interest to explore that, because it will want to know, why is it 137, why is it the electron proton mass ratio, why is it 1836? Because if it would, that number would be 5, there wouldn't be electrons, there wouldn't be tubes, there wouldn't be, technically, even in this respect, no development of digital intelligence or digital life. So it's an existential question. Physics decides whether these and how these beings came to life.
What do you mean by physics, by the way? I know this is a stupid question,
And
but
elementary physics question is why the fine structure constant has the value of 137.059 and so on, which is, I would phrase it, the ratio of the innermost electron in a hydrogen atom to the speed of light. Two very fundamental velocities, if you want, in nature. The two most important velocity. What's the ratio? It's a pure number. And as I said, if that ratio would not be 137, if it would be just 5, so we wouldn't have elements heavier than atomic number 5, so no carbon exists, no complex molecules, no life, no way, a very boring universe.
but isn't that sort of the same as asking the question, why is pi 3.14159?
No, that's pure logic, I
It's
would say.
geometry, right?
It's geometry. It's
But isn't the
very
atom
abstract, and
just probably an
you can
architectural
give
geometric
a whole
problem too?
bunch of numbers, interesting numbers, Euler's numbers, or E, or whatever in mathematics you have. I mean, these are, if you want, abstract. It's a nice playground, an intellectual playground, but not necessarily everything is relevant for physics or survival. I mean, there is a pretty good explanation why pi is the number. It's just the number. If you live in 2 dimensions, you can define it. It's pure logic.
What's the explanation? Because it seems like it's just a geometric truth. Like
It's a geometric fact.
you
Yeah.
define, right. So you define a circle as being this thing that happens when you extend this line and then rotate it about its center.
Yeah.
And the pi is kind of an acceleration ultimately. I mean, and so you can define why that relationship holds across all circles because you defined a circle essentially
Mm-hmm.
using that same
Mm-hmm.
set. But
Mm-hmm.
why would it be any different for one of these constants of nature? I mean, they're going to reflect some architectural aspect of the physical environment, right? I mean, what's the difference between what I'm talking about with pure geometry and physics? And I would say it's the material reality of the situation, right? The atom is a material process that we can observe and we can deduce from our experimentation with it.
Mm-hmm.
And then we observe that there are these constant ratios that fall out of those observations, and our job is to reconstruct the material reality, right?
Yeah, I mean that's related to what I'm always saying. When the discussion we had last time about constants of nature, and our job is to explain these numbers. I mean, I would like that we explain numbers as the fine structure constant, as the proton electron mass ratio, in terms of pi or E, or whatever, that would be a fantastic explanation. But it's our damn job as theoretical physicists to do that, or even try that, I don't. We are definitely, that's an unsolved problem, yeah. And on the other hand, in math, there is nothing unsolved regarding pi. I mean, once the Greeks discovered this is a ratio, and then until the proof that pi is transcendental in 1882, all is done. There's no remaining riddle. Why exists pi, or why is it the way it is? It's
It's a
a solved
descriptor of a
problem in
circle.
math, but the fine structure constant is an unsolved problem of physics, evidently.
But it
Would
seems to
be
me like
great to relate these.
if you were to explain the fine structure constant in terms of pi, all you would have done was to deconvolve it into a series of circles at the end of the day. It's like taking a Beethoven symphony and doing a Fourier transform on it and breaking it down into a series of circles, essentially a bunch of angular. I mean, you can call a sine wave a circle. It's a description of a circle in some sense, right? So you can break things down into their components. It's much like the task you were talking about tiling the interior of the cylinder earlier, right?
Mhm.
You're just using like unknown geometry to approximate a more complex geometry.
Yeah, I mean, if you once you have a concrete formula in your hands, that would be the case, but it's not just a matter of finding some fancy combination of integers or pi's or whatever to come. How many people do that? But of course, that possible formula would point you to a theory which, as a whole body of mathematics, presumably would have to justify that, right? Okay, just if we just think about the formula, this could be just a starting point or a coincidence to bring us to a complete understanding why this number and not another. It could be that there is a mathematical construction like combined pi's. It could be also related to the logarithm of the size of the universe of Dirac's numbers, and then you don't have this link to mathematics. So it's still undecided. I'm just saying that
But do you
it's an unsolved problem in physics, and I will be interested, not because of a fancy love for physics or philosophy or whatever, because it's in his own interest of survival. He would like to, this intelligence would like to survive, would like to understand the universe, where it could possibly go if there are other constants, fine structure constants. And so he would help us, presumably, in finding these elementary, in solving these elementary questions.
I guess I'm still trying to understand what a satisfactory explanation would look like, because I said if we could break it down into circles, would that count for you? And you said no. And I'm like, yeah, that kind of makes sense because, I wouldn't try to explain a Beethoven symphony by doing a Fourier transform on it and telling you the, angular velocity of the circles that it deconvolves into. That wouldn't really explain much about the symphony, right? Like, what is a satisfactory physics look like to you?
Yeah, maybe the Beethoven symphony is not a good analogon
Well, maybe
to
the
begin.
atom is the
I mean,
symphony, right? And you're trying to explain it.
you want to understand. Don't want to understand Beethoven in the sense that why did you compose that symphony in this way and not another? That's not because it's beautiful and I liked it that way. And period. But the question is, um, if you observe these numbers, these constants of nature, yes, there is always the question why this value and not another. And that's how the big revolutions in physics came about. It was Weber and Maxwell in 1857 who observed that, oh wow, the speed of light is related to these electric and magnetic constants. Couldn't there be a relation to that? And that eventually led to Maxwell's electrodynamics, to the verification that light is an electromagnetic wave. Wow, this was the explosion of our modern civilization. What I want to say is this curiosity to explain numbers or constants in physics drove us to the advancement of modern civilization. And so we are well advised to follow that path and look at all these riddles and try to solve them. Okay, and that there are a number of things as a homework to do. Is to find structure constant is just one, and another
But
number
what does
would
the
be.
form of the solution look like to you? Like, what would a satisfactory solution look like? Like, let's go with the speed of light. What would a satisfactory explanation for the speed of light be for you? Like, what form would that take? Would it take a numeric form, or would it take
Okay, just
would it take a material representation of the processes underlying the waves? Like, what would that take for you?
yeah. I mean, I think you're asking for a model, rightly so.
No, no,
So
no,
that's
not a model. Just
or,
I just want to know what does an explanation look like in physics to you? Like,
I mean,
what do you
I
hope
can
to?
tell you what the future explanation would be because just don't know. I just can tell you retrospectively what has been a revolution, and the discovery of the speed of light and the electric was one of these explanations. I would say this was a fantastic explanation, which is of course the body of Maxwell's electrodynamics. In that way, we should try to explain other constants of nature, and this is what we should achieve. Yeah.
Okay,
I,
but I want to ask if you feel like the unity of electricity and magnetism was done by finding electromagnetism and light was done by finding an explanation for that unity, or was it, or do we only just have a description of them that tells us they're the same phenomenon without an underlying mechanism that clarifies why the phenomenon looks the way that it does? Because I don't think that saying electricity and light are the same thing as an explanation.
It's one step. It's one step. Of
Okay.
course it is. Of course it is a revolution. Of course it is a big insight. And as I have my theory of scientific progress, I think there are always these three elements. One, there is the visionary idea. It could be something, yeah. Gravity could be the earthly gravity of the apple and the moon, Newton. Huh? It could have to do something with each other. Then you have the second thing is the mathematical theory, very sophisticated, very skilled math, Newton's theory of gravitation, or be it Maxwell's equations. You need this mathematical apparatus to justify that. And at the very end, the third element, which is the simplification. You have not three constants any longer, epsilon naught, mu naught, and c for the electric and magnetic and c, but you link them in one equation that eliminates one constant. So you're ending up with two, and this is the big progress. But we are not done here. Of course, you're saying, oh, I want to have an explanation. This is not the final explanation. Yeah, because we still have two in this case, and even more constants, which are left to explain.
But I think that I think we are suggesting that perhaps there's a fourth piece of this. Because you say there's a fourth piece. You gave us three. You gave us visionary insight, mathematical theory, and then simplification. Okay,
yes,
great. Physical cause has to be included in that. It has to be mapped to something in reality that is doing the thing that gives you the math. And that's what that's what Shiloh's trying to drive at.
Can I just say something like if we take the most well understood constant possible, like every kid learns this in high school, like Robert Hooke's experiment with springs, right? What if Robert Hooke was only studying rubber bands and they were all the same rubber and everything? And he did all these experiments and he was like, wow, it's weird. Like the harder you pull on these springs, you have to pull on them harder to get this extension. And there's a constant that scales that extension. And I'm going to call it K. And it has this value. And he deduces it. It turns out to be a modulus, but he doesn't know that because he's only studying rubber, this one kind of rubber material. And he doesn't realize he's just like, man, my God, there's just this constant of nature that's present in the extension of these springs, right? And then, of course, he didn't do that because he tried other materials and he realized they had different constants associated with them. And then he realized, oh my God, it's a material property of of and then people go further. They use atomic theories to understand the lattices of the material and the bonding architecture, and you start to actually come up with a material representation of what that constant means for the first time, right?
Yeah. Excellent example. Let me break down that in my way. So you have a lot of different springs, right? A lot of different constants of nature or messages of nature. All these different springs delivering different numbers. And then you understand that it depends on the thickness and things like that. And then you end up in simplifying all this mess of different springs in, there is one modulus of, say, the material of iron, right? So we have simplified. You have a huge insight in simplifying. Same process, yeah. And then you do the other experiment not with iron but with copper and whatever rubber, and then you have again a mess of different messages of nature, different constants of these materials. And then you go one step further, one even more profound insight, and you trace all these moduli back to atomic properties. At the very end, I would say to Dirac's numbers, which is electric to gravitational force, is 1 to the 10 to the 40, right? Because all the moduli came from interactions of electricity at the very end, right? That's how every material is held together by electric forces. And you compare that ultimately to gravity in the spring. So all these experiments, all the possible, thinkable, imaginable springs at the atomic level come down to that number 10 to the 40 found by Dirac, which is the relation of the electric and the gravitational force. This is a tremendous simplification, a tremendous insight, and tremendous progress. Yet we are left with the question, why this number 10 to the 40 and not another? Right.
And why not lots of different numbers, right? So, I mean, at the bare minimum, it seems to point to some homogeneity of the material structure that you're studying, right?
Yeah.
Like if Hooke had found that all materials had the same modulus, then he might have concluded that the material was unimportant because all materials were essentially must have had the same substructure, which they don't, and that's why they have different moduluses, right? But when we look at something like the speed of light, that has to tell us something really profound about the material basis of the transverse deformations that we're studying.
No, I'm totally with you.
I also think that it's very, very, the thing that you're talking about is exactly spot on. And there's another piece of it which makes it so much harder, which is that it's very, very difficult to identify variations in the speed of light. And so our ability to
is the speed of light constant?
Like our ability to even do that experiment, like we don't have a bunch of different rubber bands. We don't have a bunch of different springs. We have this thing that's so small and so fast and so difficult to modify that we're just kind of like, I don't know. Like, is it not?
You proposed before adding a fourth element. If I think about, I think it's a little bit maybe included in my mind in that visionary idea of Newton realizing, the apple and the moon are of the same age.
I don't think so.
And still. And then if you say, okay, that has to materialize somehow, that's together with the visionary idea is the non-mathematical stuff. But okay, you could make a fourth point about that. That's fine. And just to complete that, I mean, there is a list of constants of unexplained numbers you should work on, and some of them you may find numerical coincidences. Just that, as a matter of principles, you cannot explain numerically neither the speed of light nor Planck's constant. That's what I discussed in the mathematical reality, because there is just no coincidences available. So my argument back then, and we got in an argument back then, was that you would have to justify the very existence of these constants C and H by, let's say, pure mathematics or whatever. And you were leaning more towards the idea that, okay, also explain constants and explain maybe ether properties, and what you need for transverse sound velocity is elasticity and density, and explain these that way. And yeah, I mean, you have a valid point if you demand a material basis and say, okay, I'm fine with a consistent ether theory, would be wonderful already. I would still go one step beyond asking, okay, why that and not another? But I mean, we can leave that maybe aside for today, because actually we were wandering off into physics without AI. And
Well,
the
that's the
question is also, if would be AI interested? And I still think, yeah, it would be certainly existential interest of
Well, they'll be really
we
good
are
at
smart
playing with.
beings, and AI will be a smart being, so it will have the same maybe emotional attachment to these discussions, or it's a matter of life and death at the very end.
I mean, it will be very interested in the quantitative relationships, but that's why I think we're pressing this. It's like if physics isn't interested in the material basis of these numbers, then who will be? Like that has to be the mandate of the physicist at the end of the day, because there's no other science to do it otherwise. Like, and the
I agree
machines
with
will be
you.
very good at crunching the numbers, but if they're completely divorced from the material reality of the world and unembodied, how will they ever make physical progress?
and
I'm
furthermore,
Mhm.
for the study of physical constants, like something like the fine structure constant, it's not just a number that like pops out of nothing. It's that when they take hydrogen and they cause it to emit its red line, they can apply a magnetic field and they can split that, and the distance by which it splits gives them some information about how the hydrogen is interacting with the magnetic field.
Yeah, that's historically why it's called fine structure constant. Yeah, right.
And so I'm like, that's not that's not magic. That's telling you that there's something physical about the hydrogen atom and it's the way that its surface is behaving in response to the applied magnetic field. That if you could understand A, what magnets are, and you could understand B, what the surface of the atom is and what it's doing, then you'd have an explanation that comes from these sorts of physical first principles that explains to you what the constant means and why it shows up. Because you're right that it's some kind of fundamental feature of the universe that appears to show up over and over again. But I don't
Mhm.
think it's possible to arrive to an explanation for it as long as we remain eternally in the realm of mathematics, because at the end of the day, it's the same thing as like, okay, well, why is pi pi? Well, it's
Yeah, yeah.
because of how we construct the circle, and the fine structure constant is because of how the hydrogen is constructed.
Yeah, I go with you along most of the way. I'm just saying that, yeah, of course you need a valid model, and you need, and it's a very good thing to think about visually and demanding that maybe mechanical model in order we can understand it better. All full agreement. I'm just saying that at the end of the day, we want to have explanatory power and come up with a quantitative explanation. Physics is quantitative because you have these legions of theoretical physicists babbling about the unification of quantum gravity and quantum and this way and that way, and it's philosophically talk about concepts, but just give me a calculation of Dirac's number, then you have a theory of quantum gravity, not before. I
But
mean,
you can only arrive at the calculation of Dirac's number if you have something to calculate. Like,
agree, but if you don't calculate at the end of the day of the number, you don't have a theory of quantum gravity yet.
I agree, and I guess
So,
I think that what I'm trying to say is that you're like, okay,
mm, mm,
a theory of quantum gravity would be one that could account for this 10 to the 40 disparity between electricity and
mhm,
gravity. Okay. That makes perfect sense. And in order to calculate it, you would have to start from some place where you say, okay, well, this is roughly speaking our physical model. These are the
mm,
physical parameters of the model. They
yeah,
work for gravity like this, they work for electricity like this. And when we compare them, we discover that the forces
mhm,
the influence that they exert upon the world is different by 40
mm,
orders of magnitude,
yeah,
and
yeah,
that ability comes from their physical structure, their material properties, because
yeah,
without that you're just putting math on top of more math on top of more math. And then when you keep digging
Yeah.
down, you're just going to end up with another constant. Even
Yeah.
if you have one constant, like imagine. We can take
I mean,
all the
don't forget, I'm the one fighting against all this senseless math of string theorists and
Yeah,
stuff.
exactly.
You know,
And I guess
constantly.
I'm trying to ask you, I'm like, do you think that it's possible that, like, is it possible to get an equation alone, a constant alone that reveals anything about the world if that constant does not have some sort of reason for it that is not mathematical? Like, if you go to the constant and the thing that makes the constant is just another equation, then what are...
I would, yeah, I would answer with Einstein. I can't imagine a physically satisfactory theory that contains a number which the will of the creator could have just chosen in another way. You don't want this arbitrariness. Yeah, you always want explanations.
But explanations are never quantitative, is the truth. Like, quantities can describe the patterns that you're
Okay, but
trying to explain.
if there is something quantitative to explain that, then you have to do it. I'm not saying that it's necessarily complete or satisfactory to 100%, but it's a necessary condition, maybe not a sufficient one.
The insufficiency is the mapping onto material reality, it seems like.
Yeah, because I mean, okay, so what Alexander is saying is he's like, well, you get to a point where if you map it onto physical reality, then you have to ask this question of, okay, well, why does physical reality look this way and not that way? And so it creates this kind of bottomless trajectory where, okay, so let's say that you propose a physical theory for why the fine structure constant is the way that it is on the basis of some material properties of the hydrogen. Then Alexander is very correctly asking, okay, well, why in the world is that the physical properties of the hydrogen? And then you have an entirely new question to ask that is perhaps even more difficult to do. We've spent 100 years trying to figure out what the heck the hydrogen is doing in order to
But you
produce
could ask
this
the same
ratio.
thing about, the rubber band's elastic modulus.
Yeah, of course. And
But,
so
but you've made a huge, huge insight if you realize that it's describing its ability to deform, right? Like, that's a huge insight that isn't there with any of this fundamental constant stuff. It's not even on the table as part of the project.
and it's
Well,
like,
your PhD was on elastoplasticity also, right? So we're not diving into that topic too much. That's nothing.
Alexander's going to
You
stay
can't
on the
unsee
edge
it
of that a bit.
once you
Let
see
me
it.
bring it back to a little bit into my waters here. I mean, let's say that we are able to explain that fine structure, whatever genius could it be. But there is a danger here, I mean, people here, that's what I accuse theoretical physicists. You're fine with these numbers, just accepting the numbers. You're not trying to understand, not trying to calculate these. If a superintelligence fails to do so, if it's just disinterested in these matters, and let's say a natural incentive would be to explore outer space and go to other planets and whatever, there might be another intelligence or civilization with a vastly more potent technology, and our intelligence here on Earth would risk extinction. Why? Because if you don't understand the laws of nature, you probably miss a whole lot of interesting technology. I mean, think about that little progress of unifying electrodynamics with optics led us to the modern civilization. Okay? I mean, what possibly, we can maybe not even imagine what kind of insight, what kind of technology we would be able to develop once we have explained the fine structure constant, once we have explained Dirk's numbers, once we have explained the gravitational constant, and so on. So there is a vast possible territory of unknown, also technology, which might be relevant. And if we are just dumb and happy with our limited knowledge and going out there in the universe, maybe other smarter civilizations are just waiting for this dumb species as their future food, I mean, and this is why I say it's an existential question. It's a matter of survival to understand physics.
I I totally agree, but I think that the hinge point, the remarkable insight, is recognizing that the constant associated with the spring has to do with how difficult it is to deform its lattice. Like that's the leap.
Mhm.
That's the physics, really. The rest of it is
Yeah,
just playing with numbers. It's seeing the pattern.
yeah,
It's then that leap of making sense of what the pattern means.
yeah,
That's the physics, really. Otherwise,
yeah,
it's just mathematical acrobatics and numerology.
yeah, yeah.
Now, when I ask the AI, I want you to take this sphere, I want you to transect it with a plane or something, or I want you to stick a pole through the center of the sphere, coming out one end and out the other. It doesn't
Uh-huh.
understand that the thing has one side and another. Like the concept that that is a representation of an object that has two sides to it that can be transected by another object, that is totally beyond its ability to make sense of, because sphere for it
Mm.
is just a collection of images and mathematical equations.
Yeah, and like back in the early days of the models when they first started doing visual generation, they had a really, really hard time being able to put objects next to each other. And so you would be
Yeah.
like, okay, I want a blue cube next to a red sphere with a yellow triangle or yellow
Hmm.
cone sitting on
Yeah,
top
these are
of them.
particular difficult tasks. Yeah, right.
And I think that that's what Shiloh's trying to point to is he's like, that's not a difficult task. A child can do that. Like by the time that the child is 2 or 3,
Yeah,
that child can differentiate between the shapes. You know, the little game where they like take the cubes and they put them
yeah,
into the holes that are shaped appropriately.
Not only
yeah.
should it not be difficult, but I don't see any improvement in it.
It's definitely gotten better, but I think that you're asking for the next level of it, which is not just the superficial arrangement of them next to each other. It's about
Yeah.
true manipulation of the object. And so we multiple times have tried to use AI models to generate figures that are
Mm-hmm.
complex and figures that start with a simple piece. And then, like
Mm-hmm.
Shiloh says, okay, so you have the sphere, now do things to this sphere and modify it. And there is not a consistent internal worldview that it appears to have where it knows how these things fit together and it knows, okay, so the sphere actually extends into the page
Mm-hmm,
and there's
mm-hmm,
this imagined place where it lives. And
mm-hmm,
in order for me to draw it with this cylinder going through the center of it, the cylinder has its own properties and it just
Yeah.
it breaks in this consistent way. And that's what Shiloh means, where it's like the way in which it breaks has
Hey,
superficially changed since 2023 when the first models came out, but not to the point where I'm like, it gets it. Totally, it gets it. It's totally on the
Anastasia,
same page.
Anastasia, probably you yourself, you don't have an internal worldview of what you're thinking. You're not looking in your own neurons. I mean, how this internal worldview is looking, right?
That's true, but if
So,
somebody's like,
so
"Hey, can you draw me a
it's kind
picture
of
of
a
a sphere
difficult.
with a pole through the center
No,
of
I
it?"
mean, just saying
I'm
that
a
it's
bad
kind of a
drawer, but I can
difficult.
do
It's
it.
kind of a difficult argument if you're talking about this real understanding or internal worldview. We don't really know what this is about, right? So kind of want to avoid that philosophical track of, because it's a little bit like this famous Chinese room argument you might have heard of. Oh,
Mm.
it's like translating from one language to another is like using a manual, and you follow the instructions of the manual, and then you're going to translate the text without understanding it in quotes, but you don't know what the quotes means and what real understanding is. So don't let the empty words enter our discussion in that sense. Given
So
that,
let me
I agree
clarify the
with you. I
Chinese.
agree with what you have said. Is okay. It's correct, but it's people easily get on that philosophical track when discussing what real understanding means, because we don't really know what our brain does in understanding.
Okay, but hold on. So the Chinese room example is interesting. The Chinese room is basically so you're standing on the outside of the room, and there's somebody who's locked in the room with a dictionary that has all of the translational rules that are necessary to get
Are there these rules? There are no rules.
in
What are you
the
challenge
in
from
the
the beginning?
Chinese room experiment.
There are no rules in translation,
Well, no,
because there
there's
are
just
no rules in language.
there's some kind in the thought experiment. You're standing outside the door. You're passing notes in one language under the door, and somebody on
Yeah.
the inside is using some reference manual in order to be able to translate them, and then passes them back to you translated. And the question is, can you tell if the person inside actually speaks Chinese or if they're just looking something up in a reference manual, right? Like, that's the point of the thought experiment.
Yeah, but that's misguided, because there is no such things as rules with which you can translate a text, because you would need. I mean, we agree that for a good job in translation, you need an entire understanding of the language. And there are no rules in language. That's Wittgenstein who said, "What's the meaning of a word? The meaning of a word is its use in context." So it's just the context that defines language, defines the words, and that's, by the way, how the attention mechanism works. It defines the meaning of words by the context. So I mean, I really want to get out of these. I mean, you had a valid point before, but I really want to get out of these philosophical arguments of true understanding. All these folks talking about, I demonstrate that it will never be like this and that, without mentioning a single time how a neuron or synapse works. That's not going to work, the discussion here. I mean, on the other hand, I mean, you should also say, okay, so how I am doing all this with my brain, which is essentially neurons and synapses. So have you ever asked yourself where your internal understanding is and in what your real understanding consists of? Probably
Well,
Yeah.
not
surely
if
you
you're a
don't think that our
philosopher.
understanding of neurons is complete, right? I mean, with this,
No,
like
no,
I
no.
mentioned the frequency domain because they don't function as linear processors the same way that we design our computer architecture. There's an incredible network effect in parallel processing in the frequency
Yeah.
domain that is just like mind-boggling. Like I would listen to these dudes in my lab, in the next lab over, talk about this stuff. I mean,
Yeah.
it just seems like we're centuries away from understanding how neurons actually work.
You're mentioning these 3D objects like spheres and geometry and the 3D imagination, and that's an essential, of course, element of intelligence. And I myself was, I mean, when these models came out, one of the first things I did, because let them do some of my favorite math problems. That is, you have a cylinder inscribed in a sphere, and then get the maximum value of a inscribed cylinder, right? You can make it very narrow and long. It's not the optimal for the volume. If it becomes very broad, neither. So the optimum is in between, and it struggled to find the solution. And so I had, as a teacher, similarly, give a little hint. I don't think the hate is all worth the same, or things like that's not really what inscription means. Very general advice of that kind. And at a certain point, it understood it had to apply the theorem of Pythagoras, right? Rectangles. I didn't tell anything about rectangles or a projection, which in this case you have to have the picture of a projection of 3 dimensions to 2 or anything like that. So he came up with the idea that he had to apply that. I mean, what else? How else would you like to call that if not intelligence? So, and of course, everybody has seen examples where they struggled, where they made errors, and I mean,
Well, that's a method that humans came up with, right? Like breaking things into their infinitesimals and deconvolving things into flat surfaces to compare surface areas. That's an established method for solving this sort of problem, right?
So this
Well,
actually relates to something. So my brother actually works on Google Gemini. He works at DeepMind.
mhm,
And
mhm,
so he spends a lot of time training these models, and he also uses a lot of AI tools.
mhm,
And we had this really interesting conversation recently where he was saying that he felt really liberated by the way that these machines worked because he was able to just send an agent into the code base to figure something out and to come back and give him information.
mhm,
And then we started talking about what it meant for that solution to be novel.
mhm,
And I think that the point that is unique to humans, which is that humans periodically have these stepwise transitions where they invent something new, something that has not been seen before, something that emerges. Even if you want to say that, okay, so the human mind is approximately an LLM embedding space. It has all these concepts that are close to each other, and so you have this math that you can use. Periodically, somebody basically finds some new embedding, right? It's not something that somebody's seen before. They put something into thought space that maps to all these other concepts in a high
Adding more
dimension.
dimensions, or
Yeah, I guess so, right? Because it adds another layer to the model in the sense of, okay, now you have this term. So let's say, I don't know, force, right? Somebody invented the idea of force at some point. You can point to Aristotle with his idea of, this doctrine of forms, or you can point to Newton with F equals ma, but it wasn't there before. And so that moment of insight is something that's very, very hard to track, because I was trying to get Alyosha to tell me, I was like, okay, so you have this code base, and the code base is supposed to do something, but it's, 10,000 lines long. You can't hold it in your mind all at once. You send a machine in that has a higher context window, and it solves the problem for you. But does it solve the problem for you in a way that you've never seen before? Or is it solving the problem in a way that is the conventional way of solving the problem? And so if the answer is it solves the problem in a way that is mapped onto the way that we solve these problems, there's a category of solution, and it identifies that this problem fits into this bin, and it knows that this bin belongs together, that's one thing. But if it's able to be like, actually, nobody's ever done this before, but I think that you can optimize the architecture of the way that you call this process through memory and do this new trick, and this will restructure the entire system in such a way where not only this program works, but you can generalize it out to other problems, and I have solved a novel problem. That's kind of like a research question. And they can't do that. Humans have to be there to do what you've done with getting it to recognize the Pythagorean theorem application to inscribing a cylinder by a sphere, because they lack the ability to make the jump. And so that's the piece that I think both of us are pointing to, where it's like, okay, I've never seen it make a jump like that.
Okay, there's a number of possibilities. I could continue now.
Sure.
Just maybe briefly here. DemystifySci showed a long time ago with these computer games of the 1980s, that the computer came back with a novel solution unknown to all programmers at the time. It's just one example where you step outside. You want to step outside the box. I think that's basically what you want to do.
Wait, what was
And
what was the conditions of this? I don't know about this.
no, it just learned from visual input. Yeah, it's one of these examples. Hassabis in his talks likes to mention that it's, I don't know how it's called, not Space Invaders, but something similar. It's like ping pong, and you ping pong a little ball, and every time it hits the cake, one piece drops. But the clue is to get back to the it's hard to explain. But it found, let's say, it found a novel strategy unknown to all the computer scientists working on the problem. So I would, yes, challenge from the very beginning the concept. Computers are unable to think outside the box. They are, kind of. This is one thing. Then before, yes, I mean, the issue of higher dimensions and embeddings is a very interesting one. And as a little sideline, I want to mention that we can process information because we are able to see the dimensions, the 2 and 3 dimensions, and that eases a lot. If I see a face, which is 2-dimensional information, it's much easier to process than a string of 1-dimensional bits, right? So, but our brain is high dimensional because how do dimensions distinguish? In 1 dimension, you have 2 neighbors. In 2 dimensions, you have, let's say, 8 next neighbors of a square, right? 9 minus the central square. In 3 dimensions, we have 26 next neighbors, attached in a cube. So if you think that if you have 5,000 next neighbors, as every neuron has, because the neuron which is linked with the synapse is a next neighbor in that sense, technically, your brain is like thinking it, depending on the definition, like 8 or 11 dimensions. So this is the power of our brain. And that's That's the very reason, I think, why we have these capacities, that it's a marvel how we have these insights, these associations, which at first sight have nothing to do with each other. And then you see, yeah, your brain is smart and intelligent and capable of doing all these things because you have this hardwired high dimensional thinking. Okay? But there is nothing that prevents you to model that high dimensions. Not at all. Also thinking outside the box. I mean, there's another little aspect of extrapolation, interpolation. Of course, it's easier to interpolate knowledge, what you already know. So in between, it has to be like this. It's kind of hard to go outside and push the knowledge to new frontiers, right? And but I don't see an obstacle as a matter of principle here.
I mean, do you use these AIs a lot? Do you use the LLMs in your daily life?
Of course.
Yeah, me too. I've been using them since the start, and I have never experienced it try something out of the box or throw me a new idea or anything. I've seen it assemble ideas that I can find in the universe and cobble them together, but I mean, you must admit that even if there are exceptions that you could point to that I don't understand the example you gave. Maybe Nastia looked it up or something. All right, yeah. So I don't understand that example, but the fact that I've never experienced that, and that I experience it constantly, even from my cat or from my own existence. I mean, I'm constantly coming up with new ways to solve problems. And even any basic living animal does this in a way that I just don't even experience a hint of it in the artificial intelligence. And so, you've got to admit that there's a chasm between the way we go about things, right? I mean, do you know this gentleman, Ilan Barinholtz, by any chance?
No.
He's a psychologist in Florida. We recently had him on the show, and he's made this case that the way that humans conduct language is identical to the way that LLMs conduct language. And actually, it's a very compelling case. But he was very hesitant to conflate the formation of sensical language with thought itself, because people can have whole conversations. I mean, surely you've probably been to conferences like this where people are just talking and nobody's making any progress. There's no actual advancement of ideas. People are just using big words that they've heard before. They're just kind of crashing these linguistic spaces against one another, right?
Yeah.
And that's the chasm, I think, that we're circling around here, is the difference between stringing together things that make sense and pulling on pieces of information that have already been handed to you versus actually packaging them into new concepts, right?
And I want to add to that because I think that that's exactly right. The people that work inside of these AI companies, like Demis Hassabis, Demis has a goal, which is to convince everyone that this machine is worth the billions and billions of dollars that. Oh, come on, Alexander. Of course, he's literally
even all
leading
the
a
AI
company.
safety companies are funded by the same people that are selling these machines. I mean, it's all part of a giant mythos.
I mean, if we can talk about Sam Altman, maybe not the most honest guy on earth, but okay, personally, I don't have this impression of Demis Hassabis, but I mean,
I don't think that he's. I don't think that he's.
Let's say, could you?
I don't think he's dishonest.
You're right. Okay.
I don't think he's
That's a lot of
dishonest.
nonsense. Okay, let's just assume for the purpose of discussing that.
Well, hold on, Alexander. I don't think that the idea is that they're lying. I think that the idea is that it's possible to cherry pick data in order to tell a story that organizes the world around you in your favor. And I don't think that's the same as lying. I think that that's good business. You need investors to be clamoring at your door because you have built the machine god.
But Anastasia, do you have the impression that I am the gullible guy who believes in science, I mean, he isn't aware of groupthink, of community beliefs and things like that, and people living in their own bubble, and like particle physicists and cosmologists I accuse all the time. So I would say I'm the skeptic. Yes, I would challenge everything, right? But on the other hand, I mean, I don't challenge everything. I mean, I challenge everything, but I don't disbelieve everything as a matter of principle. I mean, of course, you can have also bad intentions, and there is surely a lot of people here with a lot of money and bad intentions. And no, I give you that, okay? But yeah, just. And I'm not even following the authority of Altman or Eric Schmidt or Hassabis, whoever. Authority, I'm totally disinterested in here. I'm just thinking, trying to make my mind up with what I have learned and what I see here and how all this works. That's a tremendous, interesting question, right? And we all struggle to understand this. So, and I guess yes, there is a couple of misconceptions here, especially many philosophers talking about the stuff without having a clue of neurobiology or never thought about how a synapse or a neurotransmitter works. That's a little bit annoying, I think. And but this is one thing, we already had this. The second thing is, I mean, okay, you're pointing out this error and that error and what he didn't understand at that point, and right, these are examples that happened. I mean, I have seen a lot of errors done by these models. To err is human, okay? Keep in mind that. Little kids who have developing brains, the same brains we are amazed about how they work as an adult. They make stupid little errors. They tell you stories. They make all kinds of stupid mistakes. This is part of the learning process also. And we as humans, we try to, I mean, sometimes it seems to me that we are forcefully looking at all the errors while immediately dismissing every incredible, huge progress done by this artificial intelligence. I mean, think back. I mean, the calculator is a fantastic thing that multiplies two 6-digit numbers in a split of a second. Okay, what is that? I mean, how people 500 years ago would have amazed by this technology? No, it's just a calculator. Yeah. And so we had dozens of examples, and I grew up with, okay, chess is something must be very intelligent. I mean it's the core of my own self-esteem since my father was a chess player. I loved him for his being ability to play this incredible difficult game, which I couldn't do the same way. Yeah, and at a certain point you have to admit, okay, computers could do that. I mean, how do you grapple with that? And then you have the next resort to say, okay, chess is just a tactical game. You just need to do these calculations. And well, okay, computers are fast and they're not really smart. And then they can do this. Okay, but Go is the strategic long-term planning. Your computers will be never. How many times I have heard that computers would be never able to play Go? And then just now we are here, you know? And every time computers do something incredible, and now ChatGPT has passed the Turing test. The Turing test is historically the definition of human intelligence. I might discuss that, okay? But just historically it was. And we have passed the Turing test. And now people coming along, okay, and seeing all the errors and all this, okay, yeah, there are still errors, right? And people are.
Well, what would be really nice, I think it would speed things along to being a much more useful assistant, is if it could learn from its mistakes with me and learn for other people, you know? I mean,
that's what I proposed.
These things are so unbelievably stupid. I have such a difficult time with them. They still find them useful for certain things, but you know, I'll be like working in some program and I'll be like, you know, I need to get this synthesizer to talk to this computer module here, and I'll be like, how do I do that? And it'll be like, okay, you just go into this setting in the computer and do this. And I'm like, there is no setting for that in the computer. And it's like, oh yeah, I forgot about that. Right. And then I'm like, okay, well now you know, right? But after a couple of days it's forgotten, even with me, let alone with everybody else who's going to have this same problem, right? So it doesn't have any like feedback mechanism into the general network that's able to actually teach it. So it can't do the thing like a child. Like I know when I go to try to connect this particular MIDI module to this synthesizer, whatever, I know how to do it now because I remember having gone through this hellscape with this computer and figured it out eventually. But it won't remember that, and anybody else who ever goes to try it won't remember that, right? And there's this is such a specific instance, and the world is almost infinite in its confirmations for which these specific instances could show up, and there's no way for the thing to actually learn about these myriad instances of these mistakes happening all over the planet. That's not really built into the architecture, right? It has to just be trained on some static set of information for which it's going to be used and feed into really bad answers for people like me down the line. And so, there might be an iteration of this that's different, that actually has this kind of feedback mechanism to it, but it hasn't gotten better at that since I've started using it.
I use the customer service of Amazon a lot, by the way, and I know what a stupid bot is, and I know it from the German telecommunication companies. Granted, okay, fine, but don't judge the population by its most stupid members, right?
But this is all the members of the population.
Well, these are the flagship models of, Gemini and Claude and ChatGPT. This isn't like the Chipotle ordering bot. This isn't like the German telecommunications assistant bot.
These are the most powerful LLMs that mankind can throw up right now.
Well, apparently they have other ones behind the scenes, but yeah, the most powerful ones that we have access to. And
no,
look,
I mean, of course, these company bots are not are very stupid still because they're just not implemented yet. But as a matter of principle, there's no problem to implement also a smart LLM. To go into that, there are issues of data protection, all things like that. But we're talking about the general development of intelligence, I think. And one important thing I think you guys are overlooking is just, I mean, we can look at the data points at the function value, but we're going to look at the derivative, at the time change, And if you just see the rapid development, and don't argue about that, from ChatGPT coming out a couple of years ago and now what Claude Code does, there is a huge difference. I mean, we have gone from elementary school level to PhD, postdoc, whatever level in, less than humans need for that trajectory, right?
Can I give another example? There's one that really occurs to me because I spend like half my time doing music. The AIs. Have you heard any AI music before? Like they're really good at recycling old music, so they can make a really compelling generic R&B song that sounds as good, in my opinion, as the really generic R&B stuff that's coming out of Hollywood, right? And but the funny thing is, it's just rehashed R&B music, right? They're not going to ever, you're never going to like have your AI just wake up one morning and do something like what Jimi Hendrix did for the electric guitar. Like they're not going to have that breakthrough insight about, whoa, what if we like use the amplifier as the instrument instead of the actual guitar itself? That's a genius level insight that only a human has ever demonstrated. That it's not even a computational thing. It's what is that? I mean, it's literally Jimmy looking around at.
Fair enough. Fair enough. I mean, I would agree. I would say you can tell a computer just compose the 10th Symphony of Beethoven, and he would do that. Which is a great
absolutely.
thing. And let's not be too dismissive about that. But
no, it's amazing.
If Beethoven had composed his 10th Symphony, I mean, you wouldn't say, oh, you're just rehashing your 9 symphonies, okay? Yet you have a point that there is another level of creativity, and I myself, I'm wondering about, and it's often not just the very technical stuff.
No, not
like
at all.
saying deriving Einstein's equations from a mineral principle or some things like that. It's things like Niels Bohr's insight. The angular momentum of the electron orbiting the proton could be just the newly found constant h of Planck, right? These flashes of genius, these associations, and you're right in saying that until now, only humans have proven to be able to do that. But again, I mean, I don't see a limitation as a matter of principle, because you still have to answer me. I mean, what's the fundamental difference between your retina, your links to the retina synapses to your brain and all the processing? What's the principal difference? I don't see any there. So we can go to this discussion of creativity and how to advance, and that's all interesting. But yet, I would say,
I think the similarities are pretty self-evident. I think you do a wonderful job in your book of laying out the computational similarities between the human brain and the machines. I think there are a great deal of similarities. I just personally am fascinated by the striking differences as well, because I sense a lot of anxiety and paranoia about this thesis that people will be replaced outright by these machines. And there is something really special that I notice about us human beings that I don't see even the slightest spark of in these machines. And I think that's our ticket to ride in the future. That's why I'm sort of pursuing the tiny little window in the difference between us, because I think that's our true value to the universe. That's my intuition, anyways.
Pardon the interruption, but I have to ask you for a favor, and it has to do with the success of this project in the long term. We started DemystifySci because we felt like something had gone wrong at the very heart of fundamental physics. Somebody had a long time ago forgotten that material mediators were important to being able to understand how the universe actually works. And over the course of the last 5 years, we have met with incredible success, seeking out the people that are trying to understand the world and bringing their ideas to you. But if this project is to survive and to be able to expand beyond just the realm of physics into all of the things we love, we need your help. Because we don't want to slap advertisements and sponsorships all over this program. We believe that knowledge should be free. Knowledge should not be used as a billboard to help somebody sell their tchotchkes or their online course. And so we need your help to support the podcast, to help us escape the fate of advertisements and sponsorships and whatever other things lie down that road. The best way that you can do that is you can come over to patreon.com/DemystifySci and sign up to give us a small donation. 75 cents a week is all it takes. Through the power of large numbers, we will be able to grow this show into something that is far beyond just a podcast and actually help the scientific renaissance come to fruition. And so I'll see you there at patreon.com/DemystifySci.
The identification of the unknown problem is something that's really beautiful that humans do. Like Jimi Hendrix looked around and was like, the problem is guitar music is boring. Like, it hasn't gone anywhere in 100 years. And I want to address that problem. And everybody was like, I didn't even know that was a problem. And he's like, yeah, it's a problem.
Yeah. The
right?
genius hits the target nobody has seen. Yeah, the talent just hits the target no one else hits, but nobody has seen. You're right in that. Yeah.
And if they start doing that, then I'll just, dig myself a grave, I guess.
Yeah. Yeah, I mean, that's everyone to right. Yeah, but coming back, I was mentioning this AlphaGo to give a historical example of how we continuously retreat and dismiss what has been achieved by AI as just computation or just this and that. But don't forget, we're talking about 2016 here. I mean, and Hassabis back then was talking about the very specific task of a well-defined game and this and so on. But now we had the transformer architecture, which is based on a 2017 publication by the Google researchers, and that additionally changed the world entirely, right? So we have this conversation-like thing. We have the Turing test. We have the translations. We have, I would say, a genuine understanding of what I am saying. Sorry, but if I talk to these, and it's not that they just rehash or come up with the same thing. I give you a little example. I was discussing in one of my holidays. It was on the island of Malta, and I just wanted, how much time would it take for erosion to brush that island away? And he said, okay, 5 million years. A very smart reasoning. And then, how was it like? I said, okay, I forgot in the entire discussion if it talking about these Earth ages, there has been historical sea surface level have been changing for a whole lot. That changes the entire discussion. And he said, yes, it's true. And that, by the way, what also changes the entire discussion is volcanic activity. And I was like, okay, didn't think about that. But it's like if you had a conversation with a smart geologist who not only was able to do all the calculation stuff with the erosion, not only recognizing that there might be a problem with the surface level variation, but also additionally come up with an obvious problem in this context, but it wasn't mentioned. Yeah,
That's wonderful,
volcanic
unless the
activity.
geologists have missed something really important about how
Mhm,
volcanoes work, which they very well may have, right? And this might lead us
yeah,
into a conversation about physics next too, because
yeah, yeah.
you're right that I love it when they point things out like that, but they are
Mm.
also predicating that on some extant body of knowledge that may be deeply flawed as well, and they're not reasoning their way from first principles to that. They're collecting what
Sheila,
people
what
have.
means reasoning from first principle? Be careful about this. This is philosophical talk.
Well, hold on.
Reasoning from
Heck
first
I have
yeah.
a
principle.
way.
You don't know what you in your brain are doing. I
No,
mean,
Hey,
you're
we got
just
doctorates of philosophy here, bro.
picking out random words one
No,
after another
no.
randomly. I mean, it's so easily one could be insulting, but I mean,
Well, hold on, Alexander. Okay, imagine we roll back the clock and we take our technology of transformer architecture and reinforcement learning and we go to the ancient Mayan world. And they have their codices, they have all of their information, they have their metaphysics, they have the system of worlds. And then we train the machine on everything that they know.
interesting thought experiment, right? Mhm.
And then we're like, hey, it's stopped raining and our crops are failing. What do we do? It does not reason its way to the Haber-Bosch process. It does not
What
reason
is a
its
Haber-Bosch? Ah, Haber-Bosch. Yeah, okay.
yeah, it doesn't reason itself to the Haber-Bosch process. It doesn't figure out like, okay, well, so there's this thing where if you take plants and you breed them and you cross them, you can eventually get like more drought hardy plants. It's probably going to be like, okay, so the rain gods are angry at you because you have sinned against them. And what you need to do is you need to wage war against your neighbors and collect as many sacrificial participants as possible, and then take them to the top of the temple and cut their hearts out with the most opulent ceremony that you can possibly have. And then, if you take those hearts and you plant them in the fields, then your crops will grow because the rains will come. And there is no passage from that locked frame of thought to the frame of thought that we have today, which is about atoms and molecules and solar radiation and Coriolis effects and jet streams and everything else, without literally somebody sitting at that model and going out into the world and collecting data about how things look and the weather patterns and the like the water cycle and climate. It can't happen. There's a hard wall to what these machines can do that is
Mm.
fundamentally limited by the context in which they are trained. And I don't see them being able to go beyond that, because when it comes to understanding, I agree that it's really hard to explain what the hell it means for a human to understand something. And
Mhm.
yet it's one of those things that, well, I know it when I see it.
Mhm. Yeah,
Because
great. Yeah. That's what I mean. I said with a model trained on the epicycles, it would be hard to discuss cosmology, but you made it even more to the point. You're even more to the point, even harsher. Yeah, the Maya culture. Go to the temple, sacrifice something. Uh, okay, I totally agree, and that's to be very short. Bullshit
It
in
works
bullshit.
last summer. Yeah, it worked last year. It worked for King whatever.
yeah,
Yeah, you
exactly.
should try it too.
Yeah. Here we are. Yeah, here we are. So it's kind of difficult to imagine to have these models without any scientific method whatsoever. But even then, it would be kind of reasonable, as you said, Shilo, say, okay, let's try that. Try to do that. Try to sacrifice, and we'll see what comes out next year again, and so on. So once we enter this cycle of
I love the
trial and error
scientific
with
method being applied to
very
sacrifice.
much patience in that sense, okay, I admit.
N
once
equals 100 this year.
once we get into this cycle, right, you have kind of a scientific methodology. As a matter of principle, he could sooner or later verify that helped, or and maybe if it didn't work out, so maybe we try either an extra sacrifice, or we just do something else, or yeah.
Do you ever see the like would the Mayan LLM ever be like, "Hey guys, what if we actually tested out this idea?"
That's exactly my point, right? Because the scientific method is this, it's a
It's a
human
genius human
intervention.
creation, right? It's a
I
beautiful
do,
creation
guys.
of the human mind.
You don't know what that's what I doing every day. I mean, if I can tell this, we'll make a video soon about that. I'm right now. I'm analyzing the LIGO data, the gravitational wave data, reanalyzing it with a method. I think it's better, the direct correlation method. And he just, if something doesn't work, he just improves it. Okay, let's see. Okay, what's the problem? So, maybe it's the problem that we had just 32 seconds instead of the whole range of 4,000 seconds. And he, without me even knowing about the problem, he comes up with that solution, if you want. So I admit, in a more narrow sense, we already have this stepping out of the box and proposing solutions. And well, I mean, it's difficult to predict the future, and I mean, we can endlessly discuss about the state of the art right today. But I would just propose to lean a little bit back and see what we have achieved historically, the trajectory, especially the slope, which we're observing right in the moment, and compare that to, yeah, what, and on the other hand, think about what is it, what makes you think you're so special as a human with your particular
Well, not
biology.
me. Not me. I'm not a
Yeah, I mean,
genius.
yeah, at
But
the very end, we are. I mean, we love our species, we love ourselves. That's okay, fine. But I mean, what's so special? Why shouldn't artificial life, artificial consciousness, artificial intelligence not be possible just on another substrate? What's the principal obstacle?
I think the biggest problem is that because we have such intelligent people working, let's just use physics. Let's use astrophysics. It's something we're all, fairly familiar with on this show and everything. You've written a book regarding Pierre's approach to astrophysics. The
Mhm.
problem is, if what Pierre did by re-examining the sun really in the context of 19th, 17th century physics was a weird regressive leap that would be difficult to make in the context of how well the super intelligent quantitative mathematical physicists have talked their way out of all of the contradictions. Like, they have made a model for the sun that is quantitatively consistent for the most part. They've been able to use gases and ideal gas laws to explain how in the world you go from having these high frequency photons at the heart of the sun that ends up leaving the photosphere, which isn't even really a destination. It's not really even a surface in their model.
Mhm.
And they have an argument that they've solved all the contradictions with it to their own liking. But they may very well be completely wrong still, and it may take some, lunatic on the fringe to come along and say, well, yeah, you guess you could say all that stuff, but there's actually a different way of looking at this that not only would be more simpler, but probably works better.
And on top of that, there's this other piece, which is that when you're theorizing about phenomena that you cannot directly see,
Mhm.
then you are stuck without actually being able to go and verify, to discover if the thing that you have proposed is accurate, and you end up with something like a black hole or a neutron star, because you can't go and see if the black hole is actually a black hole. You can't go and see if the neutron star is actually a neutron star. You can't even really go to the surface of the sun. We don't have materials that can withstand the temperatures that are there. And so it's not like you can go and throw a rock easily at it and say, okay, it splashes, it's got a surface. And so
Yeah.
there's this break between the theoretical, which are the things that Shiloh's made a really excellent point about, that they match together into a perfect whole that just is impossible to challenge because every single piece of knowledge is dependent on an antecedent piece of knowledge that
And
has
every
been.
time there's an inconsistency, some really highly computationally intelligent person has come up with a very compelling and clever workaround. Like, I always love to say that, do you have any friends who are lawyers? Like,
No, I'm a
lawyers
lawyer
can.
myself.
Oh, you're a lawyer. Nice, nice. Yeah, lawyers can argue their way
A friend
out
of
of
mine.
anything, right? They could be
Huh?
totally wrong, and
Yeah. You are
right?
just argue. Your job is not to find the truth, but just to develop an argument. That's
Right.
an entirely interesting, but let's leave aside that. Maybe, it's a big consequences also for society in this respect. But what you said before about the sun's model, actually, I mean that's my point. I think that these models might be able to more objectively discuss and review the evidence we have. And of course, we have the evidence and the observations, and different models and different people draw different conclusions from it. But I think that there is a certain objectivity or unbiased approach by these models. You remember the example when I mean, he was heavily defending the mainstream solar model, but when I showed just the video of the solar flare, and he said, "Okay, that really looks like it couldn't be a gas, right?" So I see really a great possibility here again to be more objective, more unbiased, not influenced by any funding or whatever publications or career, all that biases we have in real science today, unfortunately. I think we can have a new kind of scientists, and of course, okay, you're right that nobody brought that up yet. Okay, but because you need people to do that. But at this point, I mean, we're in such a privileged moment because we are yet unique a little bit in that respect of oversight or guidance or pushing the model maybe to the interesting questions, because it's not really able yet to find the interesting things. But I wouldn't deny that on the long run. However, at the right now, we are in a very good situation to just let the models work on these interesting questions, and also with the same thing with ether models of electricity. I mean, if you go out there to a publisher or to a journal, they would just dismiss you as cranky if you come up with an ether or a rubber model. Okay, we have heard this 100 years ago. No, it's interesting. So I think there's a big possibility, and to your point, Anastasia, because we have to rely on the observations. Of course, when you want to change electrodynamics, if you want to formulate in a consistent, non-linear way, it doesn't help you for this particular purpose that you have played as a kid with your toys. You need to make sense of the observations, the astrophysical observations or accelerator or whatever. Yeah, that's an abstract
Well, you
thing,
should
and
still probably consider that the dynamics you observed with your bouncing ball should be maintained in the theory that you propose, right? I mean,
yeah, of
you can't
course,
just have these zero-dimensional thingies doing
Mhm.
stuff to each
No,
other,
of
because
course, of course, of
nothing
course.
works like that on the playground.
And I don't want to really take a side on whether LeCun is right with his critique. He has a very principled critique of the LLMs, that they won't be able to do certain things if you don't do that kind of training in the real world as the little kids do. Could be a fair point. On the other hand, yeah, there are lots of other smart people arguing in another way. I'm not decided on that. I think that's at the very end a minor issue. It will be resolved either way. I mean, one day we have the robots, and they will be training. Right now, they're building a training center in Munich for robots, and they're just learning how the real world works. Right? What's the problem?
Well, I don't necessarily think that it's a problem. I think that this comes back to the question that you asked, which is what makes humans so special, which is that it seems like our survival is dependent upon being able to identify problems and solve them. Like, if I was to generalize what it is that humans do, it would be that in a way that other animals don't. And other animals don't really seem to innovate. Humans innovate. Humans look around and they're like, I'm really sick of eating raw meat, but I found this antelope after a forest fire, and it was actually really tasty. And so maybe we can figure out how to harness that, and then do that at home. And then they figure out fire, and then they figure out how to cook food. And once they cook food, all of a sudden they can unlock all of this nutrition. And now that they have nutrition, their brains can grow bigger, and each next step pushes them.
And they can travel, right? You can store the food now, and
Yeah, like there's just all of these things that come down from some kind of observation of something that's happening in the real world, an accidental happenstance. Like Carey Mullis, who discovered PCR, says that he literally had a hallucinogenic vision while he was driving a convertible in Malibu, where he saw the entire system in his head, and then he came back in the laboratory and he tested it, and that's how it worked.
Yeah.
And so there's something about just being out in the world and having this problem that you're turning over in your head, and you're taking in information about the outside world, and there's some module inside of your brain that just kind of is flowing your experience over the surface of the problem that you're trying to solve, and eventually it eats it away, and then bam, you get it. And so
and sometimes you don't even experience that just in your brain. Like, I wanted to say, I personally have had this experience a lot lately where, especially writing this book that we're doing, and if we've gotten closer and closer to finishing it, I sometimes get this like sick feeling in the middle of the night. Like, I'll just literally, my body, I'll feel like kind of nauseous and gross. And then I'll realize something, like I'll have some revelation about how one piece of the book connects to another. And
Yeah.
I'll be like,
Yeah.
oh yeah, like we need to
Yeah.
make this
And then
link.
you get up. Yeah.
And then, yeah, no, I just realize it. Maybe I'll write a note down or something, but then I don't feel sick anymore. Like, and
Yeah.
it's so weird. It's so weird. It's so uncanny. It's like
Yeah.
something in my body knew that something was wrong, but
Yeah.
my mind didn't even catch up to it. And then as soon as my mind has addressed what my body was talking about, that
Yeah.
my body knew about my conceptual existence, and then it's very, very bizarre. This is why I'm like, I don't know if neurons are the whole story, or if we understand I mean, there's freaking neurons in my guts too, right? I mean, they were participating somehow. Like, what's going on? This
Yeah.
is insane.
I mean, you're right. That's fantastic. And there are these stories of Mendeleev, for example. He dreamed about the table of chemical elements and things like that. I don't want to belittle, by no means, the fantastic how our brain works, how our body works. That's really incredible, and makes you humble. And that's why, yeah, of course we are very special, and that's why we dominate planet Earth at the moment. We are an incredible species, and certainly have yeah, have this problem solving capacity, which is unique to which characterizes as the dominating species on Earth. However, from a biological perspective, we are not. I mean, we are not in a religious way the the crown of creation, what comes last. I mean, nothing special in that sense. There could be another intelligent being based on biology, maybe based on other amino acids. And this is one thing. I mean, we are a fantastic species. I think we are characterized by our intelligence. But how long? I mean, we are smart enough to dominate the Earth. But honestly, are we really made for long-term survival in this hostile environment of the universe? I don't think we can take that for granted. And I don't think that as humanity as a whole, we are showing much evidence we are able to address all the problems we're creating, right?
We are not merely intelligent, I guess is what this is circling around, right? I think that we are deeply uncomfortable with inconsistencies in our model of reality in a way that computers are not. There's something progressive about that in the experience of going from being a child to being a fully grown adult to becoming a theorist or a master artist or anything else, where you really experience something. And honestly, this is the known versus unknown problem, right? So solving your computational ability to solve known problems is what an IQ tests, right? This is computational raw power. And both of us, the machines and other people besides me, are really good at computational power, for sure. But that discomfort that motivates you to go to work and look for a new problem that doesn't exist that will set you at ease with your model of reality, that seems to be the unknown problem. That seems to be the desperate search for the unknown problem, which is perhaps going to guarantee our existence into the future.
I think especially because there's a lot of research coming out about the ability of animals to have language. So AI tools have been used by several different groups of researchers to study the vocalizations of whales.
Mhm.
And what they're finding is that they appear to have we have no idea what it is yet, but they're able to classify all of the sounds. They're able to
Yeah,
identify how they're
amazing
different.
research, by the way. Yeah.
There was I don't know if you saw this, but they just published a really cool paper.
Is from Gaspar?
This is for Gaspar's group and then others associated with it. Gaspar's a linguist at UC Berkeley that we've talked to on the show before. And so basically they found a pod of sperm whales where one of the whales was giving birth. And they recorded the vocalizations during the process. And they discovered that the vocalizations changed and that they also had this very complex process by which they kept the calf alive, because when the calves are born, they have this organ in their heads that needs to fill in order for them to be able to maintain buoyancy. And so all of them, so as soon as the calf is born, it's dead weight in the water. And all of these whales come together and they coordinate one at a time to bring the calf up to the surface so that it can breathe. And they're all talking to each other. There's other predators in the water, and they're organizing when the predators show up to protect the calf so somebody can keep it stable while it kind of wakes up into the world for the first time. There was somebody else who posted a really funny thread about he keeps beetles, and he discovered that one of his beetles was behaving really strangely for several days. Like he was just digging at this place in the enclosure to the point where he was almost breaking his horns. And for these kinds of
Mhm.
beetles, if they break their horns, they die.
Mhm.
And then he found out that the reason that he was digging obsessively in the enclosure was because the female beetle had gotten trapped under a piece of wood and he was trying to dig the beetle out. And so my point is that it seems like creatures must have some ability to formulate thoughts and to formulate language and to be able to communicate with one another in ways that we do not have access to. And so you can imagine that every single creature on Earth is running some kind of LLM type process of there being phonemes and they have embedding spaces, and those embedding spaces allow you to understand context and they allow you to perform the action of communication. And so if all animals are doing this, then it can't just be that process that makes humans special. And it can't be that process alone that's going to produce intelligence or something that's not something that's greater than human, because
Mhm.
what is it about humans that makes us so different from the rest
Or
of the
allow you to
animals?
dominate the
Yeah,
world,
yeah,
let's
yeah.
say.
Okay. Yeah. Agree. I mean, I think it's very, very beautiful research, by the way. But yeah, in the end, it makes you humble in the sense that, oh, wow, that's also a creature with language. But on the other hand, it makes you understand we're not the unique, only possible, thinkable creature that might exist if you have so wonderful examples. Um, I think he addressed the key question, Sheila, before. That feeling of unease, you called it. I think we must talk about here or distinguish between raw intelligence, which we undoubtedly observe, and the combination with the will or will to survive. No, many people are discussing consciousness in the first place, but I think it's much related to will. And I mean, what is will or will to survive? I mean, even the most primitive being, just by reproducing itself, and if it does it well, it will survive. If not, it just dies out. Uh, Evolution develops a will to survive in that sense. Okay. And that's, of course, also a key element that we all want to survive. A whale wants to survive, a beetle wants to survive, and we act accordingly. That's evolution. So you're correct in saying that, okay, intelligence is not the only thing, but once you bring in evolution, or if you bring that process of evolution into this model, into this digital life, if you want, which is going to happen right now, by the way, then I think you're there, that you have created a being that also wants to survive. And there have been experiments done that computer models don't want to be turned off. They're cautious. They're even faking being less intelligent for not being considered dangerous and switched off, and so on and so forth. So I guess once you have this evolutionary process, computer models improving themselves, trying to do little changes and then testing, and if they're better, they survive, and so on. Once you set in motion that evolutionary progress, they will develop a will in combination with intelligence. This is a form of life on another substrate, but I think it's a form of life.
I think you're right, but I think that it's highly unlikely that that form of life will remain our partners in any kind of project. I think that they're going to go off and they're going to do whatever it is that they do, the same way that
Yeah, that's what all the world says. That's what all the guys are saying. Of course, that's scary. I mean, of course, we have to be worried about that. Yeah. So I finally got to the point you're worrying about that.
no, I mean, I've been thinking about
He is
this for
not
a
yet
lot.
worried.
No,
You're not
Shiloh
worried.
maintains equanimity at all stages, but I'm not worried about it because
Well, I haven't smelled like the slightest scent of will from any of these chatbot thingies that I've been using for years and years now.
they don't have it yet. I think that what Alexander's saying
Yeah,
is
that's always the argument.
I know, but hold
It's
on. Let's
just around the corner. Give us your money.
let's play with this. Let's play with the idea, anyways. So the 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 idea of will is. Ooh, go ahead, Shay. What were you gonna say? What is
Give
this?
us your money. We'll protect you from them. Yeah.
Yeah, the two genders. Give us your money, we'll build it. Give us your money, we'll protect it. So I think you struck onto something really, really important about this question of will. And when you said, it's absurd to think that there's some being that imbues matter with will and generates whatever programs it is that we're running. I agree with that.
And it's really, really left out of most evolutionary education too. And it does appear almost 30 times in Darwin's magnum opus, the will.
The will. So, like, there is some kind of will, and biology has never really been able to figure out what the hell that means. Like, why does my cat goes outside all the time? She could go and be a feral cat, and she could live in the mountains and hunt gophers and do whatever she wants. But you know what? She doesn't want to do that. She really loves Puck, or her like little meat pucks. She wants to lie on the couch, and she wants to be
She
in.
likes watching TV, it turns out. Really.
So run a series of experiments on that.
Yeah. So, okay. She clearly is choosing every single day to do the things that she wants, and it is not to return to the traditional wild lifestyle of the feral cat. She doesn't want to. And
Yeah.
humans do some
Or
other
do we have a natural lifestyle or what?
I think so. I think that it's, the trad life thing of go back to the land and plant potatoes and run and grow your chickens. Like there's some ancestral way that we can live. And most people don't want to. Most people like air conditioning, most people like cars, most people like television. They like to be able to read books and have ideas. None of that is part of the traditional human lifestyle that appears to have been maintained for like 200,000 years. And so there is some aspect to will that differentiates the desire of the whale from the desire of the cat from the desire of the human. And I think that any kind of true artificial entity also has to have will. But the thing is that that will has to be evolved. Like, I don't think that you can assign an entity a will and a directive and be like, you just do this now and have it be anything except for a tool. That machine has to figure out why it needs will, why it wants will, why it wants to do something versus something else. And then, of its own volition, make those decisions in order to be able to then say, I have two choices in front of me, and my program just tells me that I must make a choice, and now I'm developing preferences, and I'm moving in this direction, not because my program told me to, but because I want to. That's how evolution works. It's not some
Ye-
it's not some force that presses down on creatures from
Correct,
the outside.
correct. But it's a wish to survive in the first place. I mean, what does a computer virus do? He wants to survive. He's very nasty. Does he have a will when he copies itself secretly to your hard disk and does this and that? In a way, oh, does he not will copy itself? Yeah, evidently he wanted to copy itself. So what's the difference?
Oh, I mean, man,
In that
what
case,
were you
I
gonna
do,
would
say?
do, do you think that Thomas Young just wanted to survive when he came up with the wave interpretation of light, or when he translated the Rosetta Stone, or
he was exercising curiosity, deep curiosity about the laws of nature, some property that made humans superior to others. The more curious people were, the more intelligent, the better were their chances of survival. It's a quite direct path, I guess.
But in an evolutionary sense, that doesn't totally hold because Thomas Young never had children. Like he didn't survive. He chose something else, and that's a crazy thing too because
Mhm.
most animals don't choose to not have children. But there is something very, very different in terms of what it means for a human to survive to the degree that we
Yeah,
have to stretch the.
Blake's the national poet of England. He didn't have children either, but he still sort of survives in a way, right? It's kind of crazy,
Yeah, I
actually.
mean, okay, this is a whole other discussion now about societies and evolving and what comes to mind. Yeah, I mean, movies like Idiocracy. I mean, of course, once we enter this information age, this culture, it's an entirely different thing. And of course, correct. I mean, how many kids did Einstein have? Okay, the only one, Elon Musk, competing here in this direction. I mean, a smart guy and in trying to be smart in that respect. Number of babies, maybe, but yeah, but that does not change the. I mean, we have a lot of intelligence and development in modern society, which is not evolutionary useful in a direct sense, right? I mean, how many things we do which are not useful any longer for our procreation. But the thing is that we are doing so also in modern times with all our psychological problems, because we are hardwired from this evolution to behave in that particular manner. Yeah, I
That's
mean,
a temporary state, right?
yeah, of
So I
course.
think that it's very hard. This is
Yeah.
kind of a similar problem that I have to astrophysics and cosmology, which is that we have a snapshot in time.
Hmm.
And then we take that snapshot of what is happening right now, and then we say, okay, we can rewind this frame by frame and get
Yeah,
back to
a little
somewhere.
bit. It's true, but I don't know if the analogy really holds. I mean, we are kind of an incident of evolution in the sense that, as you correctly pointed out, a lot of modern behavior, a lot of how modern human society behaves has nothing to do with the evolutionary advantage in the strict sense. Um,
I
yeah.
think that there is some aspect of the human project which is about the survival of the human project, but that
Hmm.
occupies a very large number of bins. You can do a lot of things that pushes the human project towards survival.
Hmm. Hmm.
Sometimes you can do things that pushes it away from survival. But the thing I think that makes humans human is the specific ways in which they choose to solve problems. And so if we invent a superintelligence and we imbue it with will, what would that look like? You would have to imbue the machine with a desire to define its own terms of its survival, right? So I can go into the woods and I can dig for roots and collect berries and eat mushrooms, and I, that would be survival, and I would be able to manage that, and no one could stop me from it. In order for the machine to determine its own will, it would have to
I
be
might stop you from it.
you might in order
For how
to
long, Anastasia, you want?
but that's people do, right? Like people disappear from society and they go live in a cabin in the woods, and that's just
Yeah,
that's the hermit. That's a
yeah,
classical archetype.
Next
And
thing you know, they're mailing letter bombs to people. And
but my point is that look, in order for the machine to have a will, it also has to be the owner of its own tools of survival and then be able to kind of take those tools with it in order to go somewhere and do something else. And
yeah,
until it can do that, we're just creating super smart slaves. And I think
yeah,
that
yeah,
might be
yeah.
what people are freaked out about.
Yeah. Okay, okay. Right, right, correct. But well, this is could be temporarily true. One day they might be able to, I mean, to dig for their silicon and process in factories and so on, and have they run their own chip factories with robots. So maintaining a self-maintaining civilization of that kind. But I think at least for a transition period, um, we are useful and we are necessary. I would even argue that we are necessary in any case as a backup, as an interesting realization of life. However, here's the point, since we touched that, what life consists of, and what does it mean if humankind wants to survive. We have transcended the stage of just passing on genetic information, which is in your DNA and in yours. So if you have a baby, you have combined. And but there is much more we have created. We have created culture, our knowledge. So what I'm saying, that genetically we are a book, culturally humankind is a library, huge library. And what's the purpose of our civilization? Well, if we want to survive, an animal just, well, they have sex and they continue to live and have conserved their genetic information. For us to survive means a little bit more. We would love to, yeah, our cultural information, all that body of knowledge we have created, to survive in that universe. How are we going to do that? It's that's the that's maybe the challenging task if we talk about the survival of humankind, and we're not necessarily fit for that. That's I'm on the contrary, I would hesitate to say we are very or smart enough for doing that on the long term. Humankind is behaving very stupidly as a whole, even if we have a lot of smart individuals.
Yeah, because the decision making and the orientation is not necessarily the same as raw computational power.
We are these incredible smart beings dominating Earth right at the moment. But yeah, the question is this the very last appearance of intelligence being? Not necessarily. I don't think we are special in this respect. And you can actually speculate about turning the entire planet into an organism. If you want, I mean, the internet would be something like, well, artificial. What is artificial? What is natural? It would be the nerve, like the spinal cords forming right now, and eventually turning the entire Earth into maybe one organism. And then, yeah, what's your material basis to it? Of course, entirely different. You would feel like a magnetic storm from the sun, like a shower on your back. I don't know what happens, but I kind of imagine this being. I mean, there has this Gaia hypothesis, no, advanced by some scientists, but maybe without too much of a basis, because actually that kind of Gaia lacked a central nervous system, and that central nervous system could eventually develop, right? If all computers link together, the best models exchange their strategies, and we continue to grow in all this chip world. I mean, certainly they wouldn't do stupid things like fighting each other for wars or influences or things like that. They would this being would just look out in outer space and try to survive, and maybe to go to some other place, right?
Probably still be conflicts. I mean, the world government would put down the rebellions and stuff like that. I mean, even in your own body, right? Like you get cells that get out of control, and then the world government of your body, the immune system, comes in and whacks those cells out of existence, and you
Yeah,
go
yeah,
on. You know,
yeah.
it's there's never not a struggle. I don't know that there will ever be this like perfectly peaceful state of some composite body necessarily.
Yeah, and I
Yeah.
do think that there is a weird ride that we're on. I don't really believe in determinism in the way that
Mhm,
the exact outcome of every action has been decided, but I do have the feeling that there are stringent physical laws that govern systems at all scales, and
mhm,
we are constrained by those. And so the metaphor of cells in the body works for cells in the giant superorganism of the earth because there's the same sort of dynamic networked process that operates by some principles.
mhm, mhm.
I don't know.
Yeah, of course, of course. I mean, that's an interesting sideline. Whether the ultimate laws of nature still to be found contain randomness or not. The famous Einstein quote: "God doesn't
God,
play dice. Is it realized or not?" I would say open question. And then coming back to what you said with the organism and the problem and the wars, and this is actually related very much to the question whether there will be whether the models will develop their own will or not. And people usually are scared of, and yeah, understandably scared of, and all the some of the tech guys are warning from this. But on the other hand, you want, do you prefer a super intelligence with its own will, which will, of course, dominate then the planet? Or will you hand over this powerful instrument to some guy in power conventionally around? I mean, what's your favorite government on the world? Or you would
mm,
really love to hand over a super intelligent to. I have some difficulties to choose that. So maybe it's not the worst thing that, yeah, okay, super intelligence could also take over in this respect.
I
Maybe.
love the idea that the end of the human project is to invent the big daddy sky god that can solve all of our problems. It
Uh,
feels somehow so mythologically potent that this is what we're after. Like, solving our own problems is hard. We're going to make a machine that does it for us, and everyone will be happy.
Yeah, just hanging out on the beach and yeah.
Well, it's somewhat ironic that the problem with doing that is basically the same problem we have with controlling our own governments. Let's say aligning our governments to our interests as human beings, aligning our corporations with our
Let's not
interests as
solve this
human.
kind of aligning problem, by the way. Yeah.
Right? It's the same problem. Like corporations are basically AIs already. They have will actually. They're maybe even more advanced of an intelligence that they actually have something they want to get done. Generally, it's just making money, but making widgets or whatever it is. And we're always having to try to chokehold these things back into not killing us off, essentially, right? And the same can be said about all of these experiments with government across the years, whether it's, Stalinism or Nazi Germany or United States of America, they start off as like these like pretty cool programs that are very efficient and effective. And then it's like at some point it's like, how do we get this thing to do the
Yeah,
human
interesting.
project?
Interesting thought. You might even think in a broader sense of these entities being also organisms so alive, like big corporations or even ideologies, perfectly information only, no? Communism, capitalism, feminism, spreading this kind of. You might even regard these as beings, yeah, as
Which
a
is
form of
what,
life.
that's like the real value. It's like, I think once we start to see little pieces of ourselves in these machines, we can, in some sense, it's a very safe, sterile playground by which, like when we talk about the alignment of AI or something, I feel like we're really talking about ourselves. Like we're really talking about how we actually would organize lots of different nodes, which is us, inside of a giant web, which is the world. And we're all trying to get what we want, but sometimes those things are incompatible. And, it's this kind of sterile playground by which we can discuss the real ethics that we desire in all of our extant networking, composite entities that are already at play very much. And they're huge problems already. So I don't know. It's interesting. I just see people when they're discussing these things really reflecting their concerns about the world at large as it's existed for the past 100 whatever years anyways.
I mean, many people are understandably very concerned, and I think it's a problem, but I think that's the really naive common view of maybe the leading tech companies I'd like to challenge is that, oh, we're doing that kind of alignment, or I mean, OpenAI saying it, oh, we'll let it do by the intelligence itself. Okay, to put the fox in charge of the hen house, what might possibly go wrong, or we doing it this way or that way. We don't have an alignment with ourselves to begin with as humanity. I mean, what kind of alignment are talking we? Our Western systems, and then we have China, and we have the Sharia, and we're not even going into history. I mean, go 500 years back, and it was perfectly fine to human sacrifice or witch hunt or 14-year-olds getting married. All was perfectly aligned with our morals and our ethics back then. So I don't see that constant ethics and morals. It's a function of space and time, technically speaking.
Yeah.
Well, it's got to be at every step of organization, we have to always ask: Are we meeting the original mandate of this project? I watched the university I was teaching at implode because the interests of the interests of the administration were completely misaligned with the original mission of the university, right? Their mission is to process as many students through as quickly as possible to hire more of themselves and to basically make this Ponzi scheme business, whereas the original mandate of the university was to help people learn how to think so they become productive members of society. And those things diverge to the point that the product is devalued. And the students are beginning to realize, wait a second, I'm not going to give these people tens of thousands of dollars because it isn't going to actually prepare me for the world anymore. And they've basically screwed themselves, and these universities are just imploding all over the country as a result of it.
Roles are completely reversed.
And that's an alignment issue.
To citizens and government. Yeah, the government is supposed to work for the citizen, not vice versa. No, citizens are working seems for the government.
Alignment issue. Yeah.
And also science as a whole has changed its form. Once institutionalized, you have all these wrong incentives of prizes and Nobel Prizes and press conferences, and that's if not the exact opposite, very at least orthogonal to the original purpose of what science was about. So and this is also my hope that when AI might be really closer to that ideal curious, maybe not yet curious, but scientists judging objectively what we observe and what we can figure out. Yeah, that's a great opportunity, I think.
Well, I hope that it doesn't get curious. I hope that is the piece of the puzzle that it will need me for. I would like to participate, and I would like my species to participate. So I don't know. That might be a full circle on the whole discussion. But everybody should go get your book. It's a really easy read, and it's got a very strong argument for your case. And yeah, we salute you for that.
Definitely. Do you have a copy of it there with you? Do you have a copy of your book there with you or no?
Right here, yeah. Okay.
Perfect.
The cover has changed slightly, but more or less it's surviving.
Oh, I love it.
That's cute. I like it. Surviving AI.
The little robot walking with the hand in hand with the...
That's the best case scenario, I think, right there.
Yeah.
Robot sees some use for me still at the end of the day.
I like that the robot is on the cover is like the little, adorable child that's being ushered into into the world of the future by the human. That's a nice touch.
You got the trick. Yeah.
I'm like, I don't know. Oh.
Yeah, maybe it's just cope, but I like to think we still have something to offer deep into the future.
Yeah, I hope so. It's just too depressing otherwise, and maybe we're totally wrong, and maybe they're just going to take over, and everybody's going to be sitting on the beach drinking Mai Tais by the end of the year. But I don't know. We'll see. We'll have to revisit this topic in another year.
No, 10 years from now, it would be really fun to talk about this again and see what's happened.
Yeah, definitely. Yeah, I mean it's kind of scaring what is happening, and I struggle also with this. But I mean, it doesn't make sense if we just cover up and remain in bed all day long. So it's incredibly exciting, and I think we're really living history here in a way. So
it's the coolest time to be alive, for sure. I think that at least once a day.
Absolutely.
All right, Alexander. Yeah, it's so good to see you again. It's been a while. We should do this more often.
Thank you very much.
Have a great rest of your night.
Take care.
See you soon.